An improved space heater lowers energy bills. A new scientific phenomenon, not previously identified, stated, or used, will positively impact your energy bills. With this, you can blow out a candle at a distance of 50 feet or more. To show where this fits in, I will give a very brief history of home heating. The inefficiency of fireplaces and chimneys is well known and well documented. 80 to 90% of the heat generated by combustion goes straight up the chimney, warming nothing or no one except the environment. This severe limitation of fireplaces was mitigated in part by building and fueling multiple fireplaces at considerable expense. This was followed by central heating with a single large furnace and pressurized ducts leading to individual rooms. Central heating was a definite improvement over multiple fireplaces, but it also has significant limitations. One of the biggest is that it typically has a single thermostat, which means that all areas of the house are set to the same temperature, whether they are in use at any particular point in time or not. The house shown here has central heating, forced air, and a single thermostat. All of the rooms in the house are set to the same temperature. So, if the thermostat is set to 68 degrees, that same temperature applies to the living room, the bedrooms, the kitchen, the office, the bathrooms at all times, whether in use or not. At night, when sleeping, both the bedroom and the kitchen are at 68 degrees, even though the kitchen is not being used. And at 10 a.m., both the bedroom and the office are warmed to 68 degrees, even though the bedroom is not being used. This inefficiency could be mitigated in part by using space heaters to augment central heating. They warm only a small space rather than the whole house. But space heaters also have serious limitations. They consume lots of energy, typically 1,500 watts each. They contribute to house fires because they're so hot. They present challenges for children and pets, and they are not stable, easily knocked over. But most importantly, most of the heat they produce goes up, vertically, rather than horizontally, and even with fans, it is very hard to move their air horizontally. In this example, it is quite possible that 3 feet horizontally from the space heater, there is very little air movement and heat. A solution would be to mount a fan and an electrical resistance heating element inside an enclosure. Heated air is then forced through a conduit to a destination at some distance away. Some heat may be lost through the conduit along the way. This is a good thing, warming the area through which it passes. Here's a little demonstration model I put together. This is a coiled irrigation tube 50 feet long. On one end is a hairdryer with a funnel. The other end goes into a cookie tin, which acts as a windbreaker for a candle. I shot this outside, so the tendency was for the wind to blow the candle out. Other than that, the cookie tin serves no other function. I turned the dryer fan on low speed. It took 32 seconds for the air to travel through the tube and reach the candle, at which point it blew the candle out. I then turned the fan on high speed, where it only took 6 seconds to blow the candle out, but this may have been in part due to leftover residual air pressure from the previous demonstration. Whether it took 6 seconds or 32 seconds is not important. What is important is that the conduit carried the airflow from the hairdryer to the far end through 50 feet of tubing, blowing out the candle. During this, I let the dryer on low temperature setting, but whether on low or high, as surely as this carried the air, it would have carried the warmer air as well. Here is the principle, although I am still working on the final wording. Whereas a pressurized fluid, either liquid or gas, within a vessel quickly loses its pressure to ambience when exposed to an unpressurized space, that same fluid retains its original pressure when traversing an unpressurized space if it is contained within a conduit subject to fluid friction. You may be asking, how can it help me? It allows for more efficient and more even heat distribution both to and within a room, allowing for each room to be a separate HVAC zone. So I can imagine Google, turn down the heat in the spare bedrooms. Alexi, turn down the heat in the office, living room, and kitchen while I'm sleeping. Hey Siri, turn off the heat in the kitchen while we're watching TV. The fan blows warm air through the conduit, which may be positioned like a baseboard heater around the perimeter of the room. In this desktop model, the mailbox makes a nice enclosure for the fan and the heat source with a vacuum cleaner hose for the conduit. The heat source may be an electrical resistance heating element, but light bulbs are also good, if not better. This deserves more detail. I measured the temperature at the base of a 4-watt LED chandelier light bulb from Dollar Tree at 141 degrees Fahrenheit. The white base is hotter than the larger globe. The small but powerful fan below uses about 5 watts, so together the fan and light burn about 10 watts per hour. The current nationwide average for 1 kilowatt, 1,000 watts per hour of electricity is about 18 cents. So the fan and the light consume about 10 watts per hour, or about 240 watts in 24 hours. So you can see the math there. This means this pair, the fan and the light, runs for 24 hours at a total cost of about 4 cents. That's 141 degrees for less than a nickel. A different light bulb may be even better. Walmart still sells an old-style 25-watt incandescent bulb. It's a little hard to see, but here is the bulb, a fan, and an enclosure, which is a cookie tin. I measured the temperature of that light bulb at 377 degrees Fahrenheit. The fan and the 25-watt light bulb use about 30 watts per hour, or 720 watts in 24 hours. You can see the math there. This pair, the fan and the light bulb, runs for 24 hours at the total cost of about 13 cents. That's 377 degrees Fahrenheit for 24 hours for 13 cents. Here's a helpful comparison. The space heater uses 1,500 watts per hour, which is about 27 cents per hour, or $6.48 for a 24-hour day, and that heat is confined to a small area. But using a 25-watt light bulb producing 377 degrees Fahrenheit and a 5-watt fan, the system on the right costs about a half a penny per hour, or 13 cents for a 24-hour day. And that heat is spread over a much larger area. This allows for individual control of each room in the house, and this can easily be controlled during the day and night. So I set up this little demonstration here. The living room, office, and kitchen during the daytime are set to 72, but at night they're set to 66. The master bedroom and bathroom are at 60 degrees during the daytime and 66 degrees at night, and the unused bedrooms and the guest bathroom are all set to 60 degrees at all times, except when you have company. Inexpensive half-inch irrigation tubing may be used instead of vacuum cleaner hose if you have a much longer run, and this tubing could be incorporated into base molding or quarter round in rooms. Additional implementations. In winter, snow and ice can accumulate on roofs, causing frozen burst pipes and even collapse of the roof itself. The irrigation tubing conduit may be run under roofs and around roof perimeters to mitigate the buildup of ice and snow and the formation of ice dams. Pipes in basements and crawl spaces under homes are subject to freezing temperatures, causing them to powerfully expand and rupture. It's hard for me to look at that picture on the right. So here we have a system installed in the crawl space of a house with another system installed in the attic. Reminder, a 25-watt light bulb producing 377 degrees Fahrenheit and a 5-watt fan for this system costs about a half a penny per hour or 13 cents for a 24-hour day. For commercial use, chickens and turkeys are warm-blooded and must be protected from extreme cold. The current industry practice is a heater at the top of the barn with forced air pushing the heat down to the birds below. Since heat rises, this is inherently wasteful and inefficient. Here are some more pictures of poultry barns showing the current industry practice of heat at the top forced down to the birds below. With the new system, heaters are placed on the floor and heat-carrying conduits run the length of the barn. Instead of being forced downward, the heat naturally rises. A larger heat source is needed here. I measured the temperature of a Walmart hot plate, $11, 900 watts, at 888 degrees Fahrenheit when on high. The heater costs only 16 cents per hour. Repeater booster heaters and fans may be positioned along the conduit. This system could be implemented in dog houses and smaller chicken coops. Reminder, a 4-watt light bulb and a 5-watt fan produce 141 degrees Fahrenheit for 4 cents every 24 hours. Here are the elements, simple, few, and cheap. A fan, a heating element, a conduit, and an enclosure. This is Improved Space Heater, U.S. patent pending. For more information, please contact John Saavedra at my email, that is my last name, Saavedra at mindspring.com. More ideas at lookforthepower.com. Thank you.